Okay, last section of the standard level bonding unit, metallic bonding. So metallic bonds involve a lattice of cations, positive metal ions, with delocalized electrons. This is what we need to understand. The first statement again. It depends on the charge of the ions and the radius of the metal ion. Alloys contain more than one metal and have slightly different properties to their parents. Right, so structure and properties of metal. So the definition that you saw talks about positively charged metal ions in a sea of delocalized electrons. And what that would mean is something like magnesium would be existing as these Mg2 pluses, which you can see here, and then moving freely around there are electrons. Right, so those free moving electrons give us very good conduction electricity. It also means that the substance is relatively ductile, which means it can be stretched into a wire, and it's also malleable, which means you can hit it with a hammer and it's going to dent and change shape. It's not going to shatter. And the reason being is that when you hit this lattice, this arrangement, the electrons can readjust so that you're not having an imbalance of charge anywhere. Whereas if you were to hit a crystal of sodium chloride, it would shatter because the positives and negatives would be misaligned and it would fly apart. It also means, because we've got this kind of glue of the electrons holding it together, we have a relatively high melting point and boiling point. Now when we talked about the ionic substances, you maybe see some familiarities between these. I did touch on the idea of a lattice energy, how much energy there was involved to break down this lattice. Now that depends upon the charges that you've got. Obviously if you've got maybe magnesium oxide, you're going to have a stronger force of attraction between Mg2 plus and O2 minus than you would between Na plus and Cl minus. And it also is affected by how well these things can pack together. So as well as the charges, there's also a factor relating to their sizes. Generally the smaller the radius, the better it will pack together and the greater the strength of that lattice. Similarly, if we have a smaller radius with our metals, then we're going to find better packing and we're going to find a higher melting point. And if we think of the charges, you think of magnesium, that's going to typically be Mg2 plus, that would be Na plus. This is giving us 2 electrons, that's giving us 1 electron. We'd maybe expect that the magnesium would have a better electrical conduction than the sodium because there's more electrons that have been delocalized. Alloys involve mixing other substances, very often a metal, in with the starting material. And so if we take our metal to begin with, then if we hit the side of it, you can see that just because it's malleable, these things can adjust and it can change to a new shape. However, we can strengthen that by adding in another substance, and that stops the structure, these lines if you like, of the atoms rolling over each other, because it's got this other material in there. Maybe it's a different size and it breaks up that pattern. And some examples of alloys are given just there. So copper and zinc will make brass, often gives it a nice appearance. It's used in brass instruments, and it maybe makes it easier to shape into trumpets and such like. If we add a bit of carbon to iron, we can make steel. And then if we take that and add some chromium, we can make it much less likely to rust and produce stainless steel, which is used in your knives and forks. Right, that's what we've covered. There's where I got some images from.